didn't give a definitive answer. School may never
Are we
know.
doing the basketball thing?
Do a thing? We could probably do a little bit, yeah. Let's finish this up and then we can play a little practical golf fun. All right, so what were we doing yesterday? A little recap. We were trying to find, we had a pretty tough one.
We were
Trying to find
using
the
the
area,
Remus thingy.
the exact area under this curve, right? Y squared minus y cubed from negative 1 to 1, right? So our strategy, remember, is to take the limit of the Riemann sum, right? We're going to take the most convenient part to calculate the rectangles, which would be the right edge, a plus I delta x. And so then it's just a matter, we always start with the same place. We're going to start with the general expression of a Riemann sum, and then we'll just plug in the specifics. So our function, f of hand, is going to be hand squared minus hand cubed, right? And delta x just 2 over n, we decided. So there's just a lot of math associated with simplifying that. But we got 2 parts to this. There's 2 levels. We've got the sigma, which is the variable of the summation is our index variable I. Any factor that doesn't have an I in it is considered a constant with respect to the sigma, right? And so the 2 over n we could pull out in front of the sigma, but not in front of the limit, because the limit is acting on n, right? Okay, so then what do we get? So if we expand everything out, we get this. And then we're just still in the process of kind of trying to collect like terms and do all that stuff. So I think we were just collecting like terms here. So we got the limit of 2 over n times the sum of, what about all the non-I terms? We get 2, just 2, I guess, right? So those guys are gone. What about the I terms? I've got this one and this one. So I get minus 10 I over n. And then the I squareds, I've got, let's see, 16 over n squared, I squared, and then 1 I cubed term. Right? Make sense? And if I get kind of lazy here, but we're going from 1 to n, and we're taking the limit as n approaches infinity, right? So, what now?
You do the sum for each one.
Okay.
Take out the constants.
Good, good. So we have the summation formulas for all 4 of those terms, right? Okay, so then we're going to end up with times. What's the sum of 2 from 1 to n?
2 times.
2n, good. Then we get minus 10 over n. What's the sum of I? Over
2n.
over 2, right? Okay. So we can do some canceling. So the n's cancel, those are like factors, and I can do that. Simplify that a little bit. Plus 16 over n squared. What's the sum of I squared?
N times n plus 1
Plus 1, good, all over 6. So we could cancel an n, and then that becomes 8/3, so that's a little better. And then finally, minus 8 over n cubed, sum of I cubed, remember that one?
n squared times quantity
N
of n
plus
plus
1
1
squared.
squared over.
Good, so we can cancel an n squared. We get that, right? Okay, so now we just gotta expand everything out, right? Well, let's see, oh man, the bottom here, we'll go to the next page. Okay, so what do we get then? Limit of 2 over n times 2n minus, what's this gonna give me? If I distribute, I just distribute the 5, right? So minus 5n minus 5. What about here? So here I'm gonna get 8 over 3n times 2n squared plus 3n plus 1, right? And then over here we get minus 2 over n times, what, just n squared plus 2n plus 1. That's look right, everybody? So n plus 1 times 2n plus 1 expanded is right there, and there's n plus 1 squared. Right? So what about here then, if I distribute the 8 over 3n, this is going to give us, what's that going to be, 16 n over 3 plus 8 plus 8 over 3n. Is that good? Or double check me. If I distribute the 8 over 3n to all parts. That look right? Okay. Is everybody there?
Yeah, yeah.
Okay. What about here then? We're going to get minus 2n minus 4 minus 2 over n. Ready by that? Okay. So if we add like terms then, what do we get here? So, yeah, I'm going to get 2n minus 2n, so those cancel. Right? Negative 5n plus 16 thirds n. What the heck's that? So that's going to be negative 15 thirds n plus 16 thirds n. So n over 3?
Yeah.
What else? So that guy's, so he's taken care of, he's taken care of. What about constants? So minus 5 plus 8 minus 4 minus 1. So those guys are done. What about over n? The other terms.
3.
So, you know,
2 over 3n, 2/3.
6,
Two- 2/3,
2 over
2/3.
3n, that's what I got, is that right?
Yeah, that's
Because
fine.
this is going to be, if I multiply by 3 over 3, I get 6
6 over-
minus 6 over 3n.
Yeah.
8 over 3n minus 6 over 3n is 2 over 3n. We're getting there. Last step,
Distribute the 2n.
say it again.
Distribute the 2n.
Distribute the 2n. It's not quite the last step.
2 over n.
So then I'm going to get 2 over 3, right? Minus 2 over n plus 4 over 3n squared. And now what happens is n goes to infinity.
Goes to 2/3.
Yeah. Two-thirds. Okay.
2/3 what?
Yeah, a lot of work, huh?
So
A lot
that's
of work.
2/3 unit squared or whatever.
Well, yeah, I mean, that's just the area under the curve is, right, so we don't have units there, right? The units are just, we're just looking at an area, yeah. We didn't give this any units at this point. So we could check that out at this point. Yeah, we could put in our calculator. So let me show you, you know how to do that on your calculators? Find areas under curves.
There's something you can
There, you can do this in your calculator. Yeah. I'll show you how. Okay, so that's what we gotta do, right? So there's a couple ways to do it, in fact. We could do it graphically. So we could go to y equals, and we could graph the function x squared minus x cubed. And then we just, let's go, so what about, to make this look good even, if we're gonna do this, let's do it right. So we wanna graph this from -1 to 1. So what could I make my window?
-1 to 1.
I could, I'm gonna go negative,
2 to 2.
yeah, -2 to 2, how about? Or negative, I don't wanna go too far, it's just gonna get big fast. I'm gonna go -1.5 down to 1.5. And then how do I get the y's to, how do I figure out what the y should be? I don't really feel like it. I'm gonna let the calculator do it for me. So I go zoom fit, which is zoom 0. Okay, and then it'll size the window vertically so it matches the curve. And so then all I've got to do here, I'm gonna tweak that just a little bit, because if I go from -1 to 1, it looks like going back to -1.5 made that window too big, didn't it? Right? So instead, I'm gonna go back, I'm just gonna manually fix that. Oops, what was it again? So probably about, I'll go up to maybe 3. So I'm gonna let my y max, y min be -1. And y max be 3. Whoops, yeah, 3. Let's stretch it out just a little bit, just so you can see it better. Now, if I want to get the area into the curve, all I've got to do is go second calc. That's where I go to all the graphic tools, right? And then which one do you think it is? It's number 7. Yeah, that looks kind of weird though. It looks like an integral, doesn't it?
Yeah.
Strange, huh? Well, it's number 7. Okay, and now I have to type in the lower limit, which is -1. Enter, and then the upper limit, which is 1. And look what it does. It's going to add up the whole area under the curve. It only gives me a decimal, but what do you know? It's 0.6 repeating. How about that? So 2/3. Okay. That's one way to do it. You can do it graphically on the calculators. There's another way, probably a quicker way.
Can you go back to the window?
To the, yeah.
Here, hold on. Following the 1.5, it's 11011.
The 1 point, oh, the delta x?
No,
Yeah, it's
I
1,
did.
-1, 3, 1.
So 1, -1, okay.
And that, honestly, that stuff doesn't really matter. I mean, I can do, like, I could just go zoom standard. I could just go zoom 6 if I want to. And it's not gonna look very pretty, but if I do the same steps, if I go second calc 7, -1, enter, 1, enter, I'm not gonna see a very pretty picture, but I get the same answer. Right? Yeah, question?
Well, so on the calculator, it was like even if I had a curve on like the cubic side as well as like what you were
Because-
Yeah. Yep. Yeah, it does the whole thing. It's gonna calculate negative area, right, as well. So let's look at, how about something like, let's look at the area under, where does this stuff come in? I just wanna see where it is in the book. I can't remember exactly. I'm talking about
His was
area. Area defined.
Okay. So then I can just do zoom.
Yeah,
Zoom.
doesn't come till
Zoom
4:3.
in.
That's probably all I'm gonna say about that for now. So that's a way to check it if you want it.
Hey, there you
Okay.
go. Sweet.
Those take a while though, don't they? Yeah. Yeah, I think I'm gonna hold off there. I'm gonna let you guys do some work on that stuff. And then we'll come back next week and I'm gonna show you something really cool about this.